Alright, this is Mr. McMurray back, and we're talking about momentum again. The computer kind of stopped on me, so I had to save what I had, or I was going to lose it all. So, going back, talking about increasing the amount of momentum. We're trying to increase the momentum, so we want more momentum. And we said we could increase that by force. So, for example, if we had, so we want to increase the momentum. And we said the easiest way, first of all, to do that, if we want to increase momentum, change momentum, make it higher. To change the impulse, we can increase the amount of force. So say you're a golfer, if you swing harder, therefore put more force on the ball. If you're a baseball player and you're batting, you can hit the ball with more force, and the same thing for tennis. All those things would help increase the impulse, which would increase your change of momentum and give you greater momentum and therefore make the ball go farther. And that would all be good. Now the other thing is the amount of time. Okay. Now if you're talking about that in terms of these three swings, a golf swing, tennis swing, or a baseball swing, this would be what we talk about a follow through. If you were just to swing, hit the ball, and stop right there, or stop shortly thereafter, you're not going to be in contact with the ball for very long. And so your time would be short, and that would make your impulse less, which means there would be less change momentum, and the ball would have less velocity when it leaves. However, if you follow through, then you're in this the club, not racket, sorry, club would be in contact with the ball for a longer period of time as you follow through. And that's why coaches are always telling people, follow through, follow through. Same thing with your swing. If you just hit the ball and kind of stop, then you're not touching the ball very long. And whereas if you follow through, you'll be touching it for a long time. The same thing with the baseball. So if you can increase the amount of time that the force is applied, and that will give you a greater impulse and therefore greater change in momentum and a greater velocity of the ball as it leaves. And that's why they can hit the ball with extremely high speeds in golfers and baseball and also in tennis. All right. I, on the other hand, not so much. One, I don't have very good force, and I don't have very good follow through, so I don't have much time. Okay. Now, another way that time could act is an example of a pistol and a rifle. Now, I don't know what these actual rifles are, but let's just say they're both a .22 pistol and a .22 rifle. That means they're shooting the same bullet, which has the same gunpowder. Therefore, when it blows up, it would have the same force to shoot the bullet out of the gun or out of the pistol. All right, so the force in this case would be exactly the same. All right. However, as long as the bullet is in the barrel, there's these expanding gases behind it, pushing it out and pushing it forward. So as long as it's in here. Now, once it gets out of it, a lot of those gases go off in other directions and no longer keep pushing or applying force to the bullet. All right. Now, in a pistol, the barrel is fairly short. Okay. In fact, if I did this to scale, it'd probably be more something like that, actually. Okay, very short. So there's a fairly short period of time that the bullet is in the barrel with the expanding gases exerting a force on it and pushing it. On the other hand, in a rifle, when I shoot the rifle, it is in the barrel for a longer time, maybe 4, 5, 6, 7, 8, 9, 10 times as long. And therefore, it is going to have 10 times as much time. Therefore, the impulse is going to be 10 times greater, and the momentum will be 10 times greater, and the velocity will be greater. Okay, so the change in velocity will be greater. Okay, they both have the same mass, so it's going to be the change in velocity that's going to be different. And so a bullet from a rifle will have a greater velocity, a greater change in velocity, change in momentum, because the force is exerted over a long period of time, whereas the pistol is a short period of time. And so that's going to affect the velocity and the change in momentum of the bullet. So if we want to increase the momentum, we get the maximum momentum or change in velocity of something, then we can either increase the force, like I said, we hit the balls harder up here, or we can have a follow through where we hit them for a longer period of time. Or in the rifle, the expanding gases act on it for a longer period of time, which give it a bigger change in momentum and therefore a greater velocity. All right, in other instances, we may be changing the amount of momentum. It's going to change. Usually something that's moving is going to come to a stop. So the amount of momentum it's going to change is from, let's just say, 20 miles per hour to 0, and it's going to change that amount no matter what. But if we can make it happen over a longer period of time, then that means it will have less force. So for example, if we have a truck that's speeding along, okay, it has a certain amount of mass, it has a certain amount of velocity. You will notice that while the truck is moving, it has the same amount of mass and it has a velocity, okay, same amount of velocity. Now, if that's going to be equal to the impulse, all right? If it hits a haystack, it's not going to stop right away. It's going to slow down over a longer period of time, and therefore it's a big amount of time. Now, the momentum is going to equal the same change of momentum. It went from, say, 20 miles per hour to 0, okay? But since the time is big, that means the force that the truck feels is relatively small, and therefore it will be relatively unharmed. On the other hand, a truck going the same speed hitting a brick wall, the time that it takes to hit the brick wall is not much. The force of it hitting the brick wall is condensed into a small amount of time, and therefore, since it's changing the momentum the same amount from 20 down to 0, that means the force the truck feels is going to be very large, okay? And so that is a bad thing if you're in the truck, because now the change of momentum is the same. It's going to equal the same amount of impulse, but if it's mostly time is big, then you're not going to feel much force. If time is small, you're going to feel a lot of force. So the faster the force is applied, and the change in momentum going from 20 miles to 0, the faster that happens, the more force you're going to feel. All right. Now, someone says, but when you hit the haystack, it only maybe extends it, say, 2 seconds, whereas here you might be talking half a second. But that's 4 times faster, or 4 times longer in the haystack that it's going to take it to slow down. So that means you're going to feel 4 times as much force when you hit the wall, or you're going to feel 1/4 as much force when you hit the haystack. It may still throw you around the car, it may cause some damage to but it's going to be in the truck, but it may cause some damage to the truck, but you're going to be in a lot better shape to walk away. So because you're going to have 1/4 as much force, or when you hit the wall, you're going to have 4 times as much force because it takes 1/4 as much time. So that's going to hurt. All right. Some other examples, the same kind of thing. If you are trying to catch a ball, or for example, say we toss eggs, if you reach toward the egg, the time that it impacts and go from whatever speed it is moving in the air to 0 and stops, or possibly even if you're pushing on toward it, it's going to go the other direction, which is going to be a bigger change in momentum. It's going to stop and actually start going the opposite direction. It's going to put a very small amount of time. It's going to put a lot of force in the egg and probably break it. On the other hand, if you move your hands, say here is the egg coming down, and if you move your hands, I'm just going to put a little cup thing here. This is your hand. As the egg comes down, if you pull your hands back this direction and catch it as it comes into your hand and move your hand that direction, that lengthens the amount of time that the egg is hitting your hand and slowing down, changing its momentum. Therefore, since it takes more time, there's less force acting on the egg and it's less likely to break. Okay. Another example, it's very common with nowadays. I haven't done it, but a lot of people have, and that is bungee jumping. Okay. Here we have someone jumping off a bridge, and they're on their way down, or possibly bounce back up. But they are attached to these bungee cords. The whole point of bungee cords is you're going to take your speed as you jump off and go into free fall. You're going to accelerate as you go down. When you get to the end, the bungee cord stretches. It's still going to slow you down from whatever speed you were going to 0 and stop down here at the very bottom, and then you're going to start coming back up. So you're still changing your momentum the same amount, okay? But it's going to be slowly as the thing stretches out. So once again, it increases the time so you feel less force. On the other hand, if you were attached to this by wire or chain or something that does not stretch, when you get to the end, it will have a really short time and such a high force it might just rip your ankles right off. Okay, so the bungee cord allows it to spread the impulse over a larger time so you feel less force. Okay, and that's basically the whole secret behind bungee cords. A similar thing too for boxers. If boxers are kind of, we were talking about the egg a minute ago, it always says to roll with the punches. Basically, that means to move in the same direction of the punch. Don't lean into the punch. If you lean into the punch, the time of the force being applied is very small. Therefore, you feel a very high force. If you roll with the punch or go the same direction as the punch, that spreads the force out over a longer period of time, so you actually feel less force. Okay, you've changed the impulse, you've spread the impulse over a longer period of time, and so you actually feel less force, and that's what they mean by rolling with the punches. Last thing we'd like to talk about in this section is similar to the same idea we just talked about. Sometimes we're going to have to decrease the momentum from a certain speed down to nothing, but instead this time we want to do it over a short time rather than spreading it out over a long time so there's less force. We want to spread it in a short time so it increases the force. Okay, for example, when a karate chop person chops bricks in half, or cinder blocks, or things like this, boards, whatever. The point is, not only do they hit with a lot of force, they also toughen up their hands so that they can not tear up their hand when they hit those with a lot of force, but they hit it and actually make their hand bounce up quickly so that the impulse is delivered over a short period of time. If the time is small, then the force delivered on these will be great. Now they also hit certain kinds of materials that when they put that force on them, it will set vibrations, and those vibrations will cause eventually the material to break and shatter. Okay, and so they can deliver more force because the impulse is spread over a very short time, and that's why they hit it hard, they hit it hard, they also bounce back from it, so the time of the impulse, time of the impact is very small, and that makes the force delivered on the material to be very high. Okay, the same thing, if you throw an egg against a wall, the time of it going from whatever speed it is when it goes into the wall to 0 and hitting the wall is very short, so it feels a lot of force and it will shatter all over the place. Okay, and we will do the activity about throwing an egg into a sheet and see how that is different. Okay, leaning into a punch, we talked about a minute ago for the boxer. If he leans into the punch, then the time of impact is very small and the force he feels is going to be greater, and therefore that boxer is more likely to end up flat out on the mat. All right. The last thing we want to consider is when something bounces. Okay, so for example, if I were to have a flower pot, not a very good flower pot. I'm going to put a flower in it. That's just not up to my skills. But okay, a flower pot is falling down. If you want to catch it in your hands, once again, I'll use a little cup shape here for your hands, it's going to take a certain amount of force or impulse to stop that pot from falling. But if you were to throw it back up again, or basically make it bounce off of you, then that's going to take even more force or more impulse to throw it back up in the air again. And basically what this shows is that anytime, if your hand doesn't move now, but if the pot hits it, it takes a certain amount of impulse to stop the pot. But if the pot bounces back up, it takes more impulse to make it go back up again in the air. And so basically when things bounce, they take a lot more impulse to do that. An example of these water wheels out in California, they used to be flat. The water would hit it, okay, and it would push the wheel around. But a man realized that if it's hit the paddle and went the opposite direction, now you've changed the momentum from 0, and now going back the other direction, that takes twice as much impulse, and therefore it's going to put a lot more force on the water wheel, which will make it go faster, which will grind the corn and do whatever that much faster. So objects that bounce, when an object bounces off, that greatly increases the impulse because there's a greater change in momentum. And we'll stop right there, and we'll see you next time.